Hello everybody and welcome to our next talk. I'm delighted to introduce Marat Lutfullin, who is CEO of Quantum Solutions, and he's going to give us a talk on Perovskite Quantum Dots color converter film in displays and sensors. As always, please leave some questions in the sidebar and we will take these after the presentation. Marat, over to you.
Okay, thank you so much, Chris. Hello to everyone. I'm Marat Lutfullin, CEO of Quantum Solutions. It's my honor to present here in TechBleak event. And today I'll talk about Perovskite Quantum Dot color converter film in displays and sensors. First of all, let me introduce our company. Quantum Solutions is a nanotechnology company that develops and manufactures quantum dot materials for displays and image sensors. We were founded in 2017 in Kau, Saudi Arabia, and today we are located in two places, first in Southampton Science Park, UK, and in KAUST. And the mission of our company is to make the invisible visible and the visible brighter and to life via new quantum dot technologies. And these quantum dot technologies includes two product lines. On the left is our QDot Perovskite Quantum Dots. They are emitting the light in visible range from 400 to 700 nanometers, and we developed them for two applications, first for LCD displays, and second for X-ray and UV sensors. Our second product on the right is QDot Lutfullin Quantum Dots. They're active in infrared range from 700 to 2500 nanometers, and we developed them for shortwave infrared image sensors. We collaborate with many sensory display companies worldwide to help to develop the new device with our materials. Now let's focus on the main topic about Perovskite Quantum Dots. First of all, I would like to talk about some basics about Perovskite Quantum Dots. Perovskite Quantum Dots are nanocrystal of semiconducting material with the common formula ABX3, where A is a monovalent cation, like cesium, formamidinium, or methylammonium. B is divalent cation, like lead or tin, and X is halogen, like chloride, bromide, iodide. The interesting thing with perovskite quantum dots that their band gap can be tuned with the changing of its composition. For example, in a center is a green vial, it's cesium lead bromide 3 quantum dots. It's emitting green light. If we add chloride there, we can increase the band gap and the emission will be tuned to the blue range. But if we add iodide, the band gap will decrease and we will tune the emission to the red light. This very unique and interesting thing with perovskite quantum dots. So you can get quantum dots with any colors. But from industrial application, the most interesting and the most promising are those perovskite quantum dots that emit green light, because they're more stable. And our company, Quantum Solutions, focus on these green emitting perovskite quantum dots. And here in the presentation, I will call it QDot sharp green perovskite quantum dots. Sharp green to underline that the emission is green, bright, and very sharp. The emission of our quantum dots are variable from 510 to 535 nanometers, depending on quantum dots loading and composition. It has very narrow fluid half-max, high quantum yield, and very short PL lifetime. In order to use this film in different devices, we developed the polymer film with sharp green quantum dot inside. Quantum dots loading might be variable with the maximum concentration up to 58%. And the first application where this film show promise, of course, for displays, for LCD backlighting. And for this application, we developed RoHS compliant film that has very high blue light absorption coefficient. The emission centered at 525 nanometers. It has extremely narrow fluid half-max, less than 20 nanometers, and high photoluminescence quantum yield, more than 95%. And perovskite film enhances the color gamut of LCD screens, while standard LCD screen can reproduce about 60 to 75% of Rec 2020 color gamut. QDot display with perovskite quantum dot inside can reproduce 85% of Rec 2020 color gamut standard.